Hello, this is Satbir. The topic of our discussion in this video is how to find the absolute maximum and absolute minimum value of a function. Let's start by looking at the graph of this function. I would like to find the absolute maximum, absolute minimum value of this function starting from point A to point B. So what is the absolute max value? It is the largest value or the highest point on the graph of the function, and the absolute min is the lowest point on the graph of this function. So to find the absolute max and absolute min, so what we first need to locate is where the derivative of the function is 0. So as you can see on the absolute max, the derivative of the function is 0 because the tangent line is horizontal. And these are the point also where the derivative of the function is 0. And here is the where the derivative of the function is does not define. So these are all the critical value of this function, but the absolute max and absolute min is the value which is the largest and the smallest value on these point. So to find the absolute max and absolute min, first we need to locate all these points where the tangent line is either horizontal or the tangent line does not exist, and then we will compare the y values on these points to identify the largest value and the largest and smallest y value of the function. Let's practice this technique on some uh, examples. So here you have a polynomial function. So I will calculate the absolute max and absolute min by calculating the critical value of this function first. So to find the critical value of this function, I will calculate the derivative of this function first in step number first. So the derivative of this function is f prime of x is 6x square minus 30x plus 24. If I pull out 6 from the derivative, because it's a common, it's a x square minus 5x plus 4. And I can factor this polynomial, and I will get a factor x is equal to 1 and x minus 4. These are the factor of this polynomial. And in step number 2, I will find the critical value of this polynomial. So I will set the derivative is equal to 0, 6 x minus 1 and x minus 4 is equal to 0. This gives me x is equal to 1 and 4. So these are the two critical value of this function. In step number 3, I will compare the y value to find the absolute max and absolute min. So this is the original function f of x. These are the x value. I will start with the endpoint 0 and 6, and I will include all the critical value which are lies in between these point 0 and 6. 1 and 4, they are both critical value which is lies in the interval 0 to 6. Once I plug 0 into the function, my y value will be 7. If I plug 1 into the function, my y value will be 18. If I plug 4 into my function, my y value will be negative 9. And when I plug 6 into my function, my y value will be 3. So as you can see, this is my smallest value of the function, which is gives me absolute minima minimum, and that is the largest value largest y value. This is give me absolute maximum. Therefore absolute minimum is this point, which is a 4 comma negative 9, and absolute maximum is this point, which is a 6, 43. Let's look at the graph of this function and see whether we find the right answer. So here, this is the graph of the function. As you can see that we only look for the maximum and minimum value starting from 0 and 6. So, and there are two critical value within the interval, which is this one, where the tangent line is horizontal. And also the endpoint are also the critical value always, because the derivative normally doesn't exist at the endpoint. So we'll also include these as a critical value. And then we plug these critical value or check there what is the highest y value. So you can see that the highest y value is 43 around here, and the smallest value is a negative 9 on the graph of this function. So these are the absolute max and absolute min. So by just looking at the graph of the function, we can also find the absolute max and absolute min. Here I have another problem where it will be a bit more challenging to find the critical value of this function. So let's begin by taking the derivative, this problem, f prime of x. So since this is the product of two functions, I will use the product rule to calculate the derivative of this function. So the derivative of the first function is 4/5 x to the power 4/5 minus 1, which is a negative 1/5. Second term as it is, x minus 4 to the power 2, and then x to the 4/5 as it is. And the derivative of the second function is going to be a 2x minus 4 to the power 1. So now this, if I simplify this expression, is going to be a 4x minus 4 to the power 2 divided by 5x to the power 1/5. And this term is simply 2x minus 4 x to the power 4/5. So since in order to add these quotient, I have to have a same denominator. So I will multiply this term by x, 5x to the power 1/5 on the top, and I will do the same thing, 5x to the power 1/5 on the top. So when I add them, now I can add the denominator because the denominator is same. So it's going to be a 4x minus 4, the square of that, and this is going to be 10 x to the power 4/5, x to the power 1/5 become x to the power 5/5. So this will become just x, and this is the x minus 4. Whole entire thing is divided by 5x to the power 1/5. So if I pull out x minus 4 from the denominator term, it's going to give me a 4x minus 4, and that is just simply 10x divided by 5x to the power 1/5. So that's simply, if I simplify this one, the simplification lead me to x minus 4, and this is giving me 14x. So this will give me 4x minus 16. So that 4 plus 10 is 14x minus 16 divided by 5x to the power 1/5. So therefore the critical values are, if I put the top is equal to 0, I will get x is equal to 4, and x is equal to 16 over 7. If this value is this factor is going to give me 16 over 14, which is basically 8 over 7. So I will get 8 over 7, one critical value. And if I put the denominator is equal to 0, I would get a critical value 0. So as you can see that 0 critical value is not in the interval, because interval is starting from 1 to 5. So 0 is not in that interval. So I will reject that critical value because this does not lies in the interval. So next I will do is I will draw the table and plot these critical values here. So this is my table x. This is my f of x. I have my endpoint starting from 1 to 5, and my critical value is 8 over 7, and another critical value is 4. And then I will calculate my y value. If I plug 1 into the function, I'm going to get 9. If I plug 8 over 7 into the function, I will get 9.08. And if I plug 4 into the function, I will get just simply 0. And if I plug 5 into the function, I will get 3.62. So as you can see that this is the smallest value of the function. So this will become the absolute min. And the largest value is this. So this will gives me the absolute max. Here you can look at the graph of these functions, and as you can see that our absolute min occur at 4,0. So this is the point where the absolute min is upping. Absolute max is the occur at 8 over 7, so which is basically slightly greater than 1. It is here. So this time this does not occur at the end point, both absolute min and absolute max. Here I have one quiz problem. You can practice on it. Please pause the video for 1 or 2 minutes. And once you have the answer, you can submit your answer in the link above to compare your answer with the other audience who is also taking this quiz. I have 2 more problems for us to practice. So the next example, example number 3, is to find the absolute and find the extreme value of this function. So I will start again by taking the derivative of this function and find the critical value of this function first. So solution. So the derivative of this function f prime of x will be 1 minus, this is a x to the power 1/3. This function is a x minus x to the power 1/3. So derivative of x is a 1. So it will be 1/3 x to the power minus 2/3. So now I will simplify this derivative. This is going to be 1/3. This is means 1 over 3x to the power 2/3. Now I will make the same denominator. So I will multiply in the denominator term of this 3x to the power 2/3. If I multiply something in the denominator, I have to multiply same term in the denominator as well. So this gives me the simplest derivative is 3x to the power 2/3 minus 1 and divided by 3x to the power 2/3. So step number 2 is finding the critical value. So to find the critical value, you have to put the top and bottom both is equal to 0. If I put the top is equal to 0, x to the power 2/3 minus 1 is equal to 0. This will be basically x to the power 2/3 is equal to 1/3. And that gives me, if I cube on both sides, if I take the cube on both sides, it's going to be x square is equal to 1 over 27. So therefore, this will give me x is equal to square root of 1 over 27 plus minus 1, which is the same as plus minus 1 over 3 square root of 3. And if I plug the y value, the bottom is equal to 0, this is a 3x to the power 2/3, or the denominator term, that gives me x is equal to 0. So I have critical value 0 and plus minus square root of 3 square root of 3. My interval is starting from -1 to 4. So I will take all the critical value which is lies between -1 to 4. So 0, so this one is first negative 1 over 3 square root of 3. Then there is a 0 and there is a 1 over square root of 3 square root of 3, and then we have 4 here. So let's plug these value into our function and find the y value of the function. So if I plug -1 into the function, I will get 0. If I plug this value, which is a -1 3 square root of 3, I will get 0.38, 0.38. 0 gives me 0 because everything is 0. This gives me 0.38, but this time it's a negative 0.38. And 4 gives me 2.41. So as I can see, this is my largest value of the function. This is my largest value, and this is my smallest value. So this is the absolute minimum, and this is the absolute maximum value of the function. I have one more problem, which is even more challenging than the previous one. Here I have a and b, which are both positive number, and I have to find the absolute max and absolute min value of this function between 0 and 1. Let's again begin by taking the derivative of this function. So f prime of x will be by using the product rule. So derivative of the first term is a x to the power a minus 1, and this is a 1 minus x to the power b as it is, and then I will take the derivative of the second term, so it will be x to the power a as it is, and now I have 1 minus x, and then I have a b time, b will drop, b time 1 minus x to the power b minus 1, and time the derivative of inside outside, which is a -1. Now I will pull out the smallest exponent, which has the smallest exponent. If it has a common factor, you can see x is a common and 1 minus x is a common, but I will only pull the smallest degree. So x to the power a minus 1 and 1 minus x to the power b minus 1 I will pull out. Here will left x a 1 minus x, and here it will left only b and x to the power 1. Now simplify this factor. If I simplify this one, this will gives me minus a minus ax plus bx. So there is a negative sign, sorry, -1 here. This will be a negative because of this negative sign. So it will change from this also negative. And eventually this will be a, because I can pull out x. So this will be a plus b times x. So that will be inside of this. So the simplest form is x to the power a minus 1, 1 minus x to the power b minus 1. And this function inside is a minus a plus b x. So in step number 2, when I will go and find the critical value of this function, so in step number 2, find the critical value. So if I plug this and that is equal to 0, assuming the power is positive, then this will give me the critical value x is equal to 0 or x is equal to 1. Even if the power is not positive, it's a negative, then you will bring that thing into the denominator. And when you put the denominator is equal to 0, you will still get these critical value x is equal to 0 and 1. If I set this thing is equal to 0, I will get x is equal to a over a plus b. Since a and b are both positive, so this number is all will be less than 1. So now what we will do, we will going to calculate we're going to plot the tables and then calculate the critical value of this function. So here let's plot the table. So this is my f of x. This is my interval is starting from 0 to 1. I have a critical value 0, 1, and then this critical value critical value a over a plus b is inside of the 0 to 1. So I will plug that into my function. If I plug 0, I get 0. If I plug I get 0. And this one is, if I plug this one, I'm gonna get a plus b to the power, because the function is x to the power a. And then we'll get 1 minus a over a plus b to the power a to the power b. So you can see that this is a positive value. If I simplify this a little bit, I will get that b on the top. If I simplify this, it's gonna be a plus b to the power a, and this is gonna be a plus b minus a divided by a plus b to the power b. So this values is basically a over a plus b to the power a and b over a plus b to the power b, which is a positive. This is a positive value. So it means this values give me the maximum. This is the absolute max. And these are two absolute minimum, this and that. So here we have two absolute minimum values. So minimum absolute min is occur at 0, 0 and 1 comma 0, and absolute max occur at this value a over a plus b, and then that's your y value a over a plus b to the power a, b over a plus b to the power b. This is all I have in this video. Thank you very much for watching my video. If you like this video, hit the like button and also subscribe my channel and hit the bell button so you can get the next video. Bye for now. Thank you.